In this kind of problem, we have a circuit here. So this is our main circuit. We are going to find the RAB, or the resistant equivalent here. So first, before that, we are going to just to identify. So here is our point A and point B. So here is our A and B. Here is our node C and D. So to find this, so we can be able to, the total equivalent here, we can say that this is the R equivalent CD for this branch. And then here is the G and H. So if you're going to get the total resistance for this branch, we can say that this is the R equivalent GH. So the R equivalent AB is the equivalent, or the total resistance for CD and then GH. So this includes this circuit. So take note that in our voltage source, which is 27 volts, we have an internal resistance of 1 ohm. So in order for the R equivalent, so the R equivalent here is the total equivalent for, which means RAB plus the REQ. No, I mean the RAB, or the equivalent resistance for from RAB, and then we are going to add up the internal resistance, which is 1 ohm. So if we have an internal resistance, we're just going to add, this is just connected in series to the rest equivalent resistances. So here, take note that this, if we are going to ask what would be this kind of combinational circuit, we know that if we, by inspection, we know that this kind of circuit is a parallel series combination circuit. In why? It's because the last simplification of this kind of circuit will be parallel. That is why this is called a parallel series combinational circuit. So one technique to solve easily, or the most effective technique to solve this one, is we're going to solve first for the branches. We need to simplify the branches for a particular line or a circuit, and then after that we will be or from left, from right to left, and or even also for the circuit like this, we are needing, we need to simplify this circuit first and this one, so that we can solve it easily. So here, we need to solve first the, what would be the total equivalent for this branch of circuit. So we know that the 12 ohms, 6 ohms, and then 4 ohms, they are connected in parallel. So using the formula for the parallel, uh, okay, so this is just 1 over 12 plus 1 over 6 plus 1 over 4. So I think it depends on you in how are you going to designate your total resistance for this kind of branch. And then, so using your calculator, we have a 1 over 1 divided by 12 plus 1 over 6 plus 1 over 4. This will be equal to 2 ohms. 2 ohms. Okay, so we already so the total equivalent for this circuit is 2 ohms, and then so we have it here. So next to solve is for the R equivalent, or the total, what will be the total resistance if we add up, or if we combine this kind of circuit. And again, by inspection, we know that 20 ohms and 5 ohms, they are connected in parallel. So here is we're going to solve for the para. So R, so for this one, so this is 1 over 5 plus 1 over 20. And using your calculator, we know that the combined resistances for this kind of branches, this will be equal to 4 ohms. And this is it. Okay. So our next circuit will be transformed from this circuit will be transformed into this one. So again, we combine the resistances for this branch, and then we combine also the resistances for this branch, and then we have 2 ohms and then 4 ohms now. Okay, so we have that. Let me erase this one. So next step is next step. So um the current flows here. So this is so we if we have our total power supply, which is the 27 volts on, and then we could have also it's our total current, and then the total resistance will be the R equivalent for this, the combined resistances. So to find the R equivalent or the total resistance for this kind of circuit, we need to find the R equivalent AB or the combined resistances for this one, and then we combine it to the internal resistance, which is 1 ohm. So first let us going to combine the circuit or the resistances for this kind of circuit. So here, so we know that 8 ohms and 40 ohms, they are connected in series. So our next circuit would be, okay, so just okay, so 8 8 ohms plus 4 ohms is equals to, this is 12 ohms, and then 2 ohms plus 22 ohms, this is 24 ohms. Here, okay, so this is our 1 ohm. So this is, let's say that this is the internal resistance, the internal resistance of our power source. So we already combined the total resistance for this circuit and this for this circuit also. So now is to find uh, the combined resistances for this one. So using our, so this is already our, so if we combine this resistances, this will serve our RAB because as you can observe here, this is our point A and point B. So if we combine this circuit, this is already our RAB, or the equivalent circuit for, or the total combined circuit for this one. So RAB, this is 1 over 24 plus 1 over 12. So if we combine, or if you use your calculator, our RAB will be equal to 8 ohms. Okay, again, our RAB, the circuit here. So the internal resistance is not yet included. So we have now our circuit goes like this. This is 1 ohm. This is 8 ohms. This is 27 volts. Okay. So in this kind of circuit, based on the last, our last simplification, or the last simplified circuit, or the simplified circuit that we have right now is a series, right? So our assumption in the before that I have tackled, I said that it is a parallel circuit, so I was wrong. So based on the simplified circuit right now that we have a simplified series circuit. So therefore, our this kind of combination circuit, this is a series parallel circuit. So don't forget that one. So we will be basing on the last or the simplified circuit, since our simplified circuit is already in the series. So this is a series parallel circuit. Okay, so to add, so if we are going to add this one, our total R equivalent will be equal to, so since they are connected in series, so this is 9 ohms. 1 plus 8 is 9 ohms. So okay, so this is our RAQ. So we already have our RAQ, and then our RAB is 8 ohms. So the combined resistances for this one, okay, we are, so now next is to solve for the R I1, I2, and I3. Excuse me, so sorry, I am not feeling well. Okay, so let me erase this first. Okay, okay, next step is to solve for the I sub 1. So based on the circuit that we have right now, uh, just ask yourself that the current that flows here, so we have I mean, first we have a total current. So to solve for the total current, we will be using the our R equivalent. Okay, so let me recall, our REQ is equal to 9 ohms. Then our RAB is equal to 8 ohms. So let me erase this one. So if you're going to find the total current or the I equivalent for this kind of circuit, we will be using R equivalent. So this is 27 divided by the total REQ is 9. So we have 3 amperes. Okay, so how are we going to find our I sub 1? I sub 1. So we know that this is voltage divided by the resistance. So as you can notice here, our I sub 1 is just we will be using the combined resistances for the 2 ohms and then 22 ohms, because the current here, the our I sub 1 will flows here, and it will uh, go back here. The I1 is will be, ang tawag yun is babalik siya dyan. So we will be using, so as you can observe, it will flows here, and then the current that will be flows here is already the uh, our I sub 2. So if you can observe here, our I sub 1, we will using okay, so we know what, wait, let us solve first for our IAB. our IAB, let's start for our IAB first. IAB will be equal to, what will be our VAB? Okay, so let us not find for the IAB first. Okay, let me erase this one. So based on what we have saw, or what we have right now, the data that we have right now, so we know that in this kind of circuit, if we have our R equivalent here, and this is just equal to the our R equivalent will be just equal to, diba? This is, we know that this is connected in series, right? And then we could say that the current that flows here will be the same with this one, and also in our 8 ohms, right? And then this is just our I sub 1 that flows here. This is just equal to the current that, or this is just equal to our I equivalent. So our I sub 1 will be equal to, this will be equal to our, to 3 amperes also. Okay, so just take note that they are connected in series. So the current that flows in our total current, or our I equivalent, will be also equal to the current that flows in our I sub 1. Now, base here, what would be the next to solve is our I sub 2. What would be the current that flows here? We know that our I sub 2, this the current that flows here, this is already the combined. So this one, so this is, so the current that flows, we will be talking for the current that flows here. This is our I sub 2. So the combined resistances, in which if we will be if we could get the our I sub 2, it will be divided by these resistances or these loads. So now, to solve for our I sub 2, we will be using our these 24 ohms, or the R equivalent CD. Okay, so this would be voltage. So what would be our voltage to be used here? Yes, we use 24 ohms. Okay, just observe for the direction for our I sub 2. So what will be the voltage that we will be using here? Okay, so the voltage to be used here is just, okay, so in this circuit, so in this it is our simplified circuit here, we know that a 24 ohms and 12 ohms, they are connected in parallel, and we could say that the voltage of our 24 ohms is just equal to the voltage in our 12 ohms. And also our simplest form for our circuit is here. So we have internal resistance, which is 1 ohm, and then the combined circuit for this one is already in 8 ohms, right? So our voltage, the voltage drop in our 8 ohms, since this is just the combined circuit for this one, will be just equal to, since they are connected, I mean this is the total voltage, I mean, this is the total resistance for the 24 and 12 ohms. So if we get the voltage here, the voltage drop for our 8 ohms, we could say that this is just equal to the voltage here, the voltage drop here, and also here. So how are we going to find the voltage drop for our 8 ohms? So just simple, let's just using the Ohm's law, and we know that Ohm's law is just equal, so current will be equal to volt over resistance as a review. So here, how are we going to use the voltage drop here? Okay, so voltage drop for our 8 ohms. Okay, so what will be our current? Our current, since we know that this is already connected in series, then the current is just the same. And a while ago, we already calculated the total current, which is equal to 3 ampere, which is also the same current that will flows in 1 ohms, and also the same current that will flow in our I sub 1 just based on the designated direction, I mean for the given current, our I sub 1 here, and then also the same current that will flow in our 8 ohms. Again, our 8 ohms is the combined resistances for our 24 ohms and then 12 ohms. 8 ohms is our RAB, or the R equivalent of A and B, from point A and B. So therefore, our V, the voltage across, or the voltage drop for our 8 ohms will be equal to 3, 3 amperes times resistance, which is of course 8 ohms. So we have now a 24 volts. Now, the voltage, the current that flows here in our 24 ohms, which is here our I sub 2, right? So again, so just kindly combine this first so you can get the I sub 2. So we already have the voltage drop here. So here it is. So now we can use for our I sub 2. We can solve for our I sub 2 now. So the volt that we are going to use is already this 24 ohms. So therefore our I sub 2 will be equal to 24 volts divided by 24 ohms. So here we use this one. So therefore our I sub 2 will be equal to 1 ampere. 1 ampere. So now, next is to solve for our I sub 3. So what will be the current that flows here? So this is our I sub 3. I sub 3. So to solve for our I sub 3, so of course using Ohm's law, voltage and then the resistance. So our I sub 3, the current that flows in 12 ohms, again the 12 ohms is the combined resistances for our 8 and 4 ohms, and we know that 4 ohms is the combined resistances for our 5 and 20 ohms that they are connected in parallel. So our 12 ohms here, so our 12 ohms, we are going to solve for our I sub 3. So this one we will, so our resistance that we will be using, since it flows in our 12 ohms and base here, so again just combine this first so you can get the accurate current that will flow here. So the resistance here is 12 ohms. Then the voltage that you will be using is the same, which is 24 volts. Why? It is because again, the voltage the voltage drop across here, which is 24 volts, is also the same for the voltage drop that across here, because they are connected in parallel. So at this point we could say that our I sub 3 will be equal to 2 amperes. So overall, if we are going to summarize our result based on our calculations, or based on our simplifications of the circuit, so at first we have our ICE, our RAB. Again, our RAB is the simplified circuit, or the simplified resistances from this point. So the internal resistance here is not yet included. So if we are going to include the internal resistance, which is 1 ohm, and then our RAB, that is now our R equivalent, or the total resistances. So our I sub 1, or the current that flows here, so this is our I sub 1. So this is just the same for the total current, and then the total current that flows in our internal resistance, and also the same for the current that flows in our RAB. So here it is. And then we will be using the resistance for 24 ohms to solve for our I sub 1. I mean I sub 2, and then we will be using the resistance to solve for our the resistance 12 ohms to solve for our I sub 3. So overall, our I sub 1 is equal to 3 amperes, our I sub 2 is equals to 1 ampere, and then our I sub 3 is equals to 2 amperes. So that is how to solve. So again, before solving, you need to analyze first the circuit. So you will be again reviewing the parallel circuit, series circuit, its principles, then applying Ohm's law, then uh, simplify. So I think you need to perform, or how are you going to simplify the circuit. So again, just review the technique that I had discussed earlier, that you need to simplify the branches first before the others, so that you can arrive with the certain or correct answer. So that's all. Thank you.